Good afternoon. My name is Dr. Shakir. I am the director for the Candidate Empowerment Center here in the College of Education, where our program assistant is Miss Andrika Bryant. Today, we are excited to offer the first installation in our boot camp workshop series for the Florida Teacher Certification Examinations. And in particular, today, we are going to have Miss Stephanie Espy, founder and director of MathSP, a company that helps students with all things math, but more specifically helps students to prepare for various standardized exams, including but not limited to the ACT, GRE, GK, which we're going to be talking about the GK math portion today. She is trained as an engineer and actually worked in that field professionally, but a few years ago decided that she wanted to take her talents to helping students with preparing and really understanding what her true love is, math. And if you follow her on social media, she posts lots and lots of great content about math. So we're happy to have her today, and welcome to Miss Espy.
Thank you, Dr. Shakir, and thank you everybody for joining in today, whether you're with us live or whether you are going to be listening to this recording later. First and foremost, I want to say feel free to reach out to me if you have questions about the GK, anything that we discussed today, or something that you've been studying that you maybe have some questions about or some concerns. Feel free to reach out to me. I'm here to help you. As Dr. Shakir said, my passion is math and science. My degree is in chemical engineering. I love everything dealing with math and science, and I also love education. So many wonderful educators throughout my career, my life. As early as elementary school, I remember some of my early teachers. I definitely remember my teachers from middle school and high school to kind of give back in a way and sort of help the next generation of educators who are going to inspire countless students in the years to come. Today is look at the GK website, and the GK website has some sample questions that you're likely to see on the test. So I figure the best way to study for this test is to do sample questions. And not just any sample questions, but those that are provided by the actual test makers, right? The people who actually write and administer the test. Those are the questions we want to really focus on. Back and forth between screens, because I have my the GK website here, which gives us the questions, and I have to go to my whiteboard in order to actually work through the questions. So I'll be going back and forth between this screen with the questions and the whiteboard where I can actually work through the questions with you all. So this is the GK website. I clicked over to the mathematics subtest. This is one part of the test. And this test consists of approximately 40 multiple choice questions, and it's 100 minutes long. So you should know the format of the test you'll be taking. So 40 questions, you have an hour, 10 minutes, 100 minutes. So that's an hour, 40 minutes to answer 40 questions. So 60 minutes, 1 hour, 40 minutes, so almost 2 hours. So that's quite a bit of time for 40 questions. And they're all multiple choice. So you don't have to worry about anything where you have to produce your own answer. You'll have 4 answer choices for each question. There is also an on-screen calculator. So it's not a fancy calculator, very basic calculators available to you. But for any calculation, multiplication, division, you do have a on-screen calculator. So for the purpose of studying for this test, you can definitely use your cell phone calculator, or you can use a TI or HP or some other calculator or internet-based calculator to do some simple calculations. There's also a reference sheet. So there's a link here that says, and a mathematics reference sheet will be provided. So if I click on this reference sheet, it includes different equations for geometry. So you have the area equations for a triangle, rectangle, trapezoid, parallelogram, and a circle. You also have surface area equations here. You have volume equations here. You have Pythagorean theorem equation, interest equation, distance formula, midpoint, slope, etc. Unit conversions, a lot of different conversions at the bottom here. So it's a 2-page document that you should definitely be familiar with, so you know what's provided to you on the test, and so you know what's not provided to you on the test. So I recommend that you all print out a copy of this reference sheet so that you can use this reference sheet as you study for the test, okay? So if I scroll down, it gives you some sample questions. The following questions are both the form and content of questions on the examination. So there's word problems, there's questions that relate to graphics, there's a combination of geometry and algebra, arithmetic on the test. These questions will acquaint you with the general format of the exam. These questions do not cover all of the competencies and skills tested. So that's one thing you want to know. It does not cover every last competency you need to know. So it's important to know to review all the competencies. And this only approximates the degree of examination difficulty. So it's a good starting point, but you want to use it as a starting point and then perhaps get another study guide, practice book for you to continue to study and go through sample math questions. So what we're gonna do is I'm gonna share the questions on the screen, give you guys just a couple minutes to just think through it and process it on your own. So those of you that are live with us today, make sure you have pencil and paper so you can actually write down how you would solve the questions. And if you are listening to the recording, you can also take out your pencil and your paper and also try to write down, your response, work through the question. And then after a few minutes, I will then share my screen, my whiteboard, and then I'll actually work through it together. Okay? All right, so I'm not sure how many we'll actually get through in the time that we have, but we'll do as many as we can. All right, so press begin. So here's the first question. It says, which of the following symbols should be placed in the box to form a true statement? And you see at the very top, it says competency number 1, which is knowledge of number sense, concepts, and operations. All right, so this one shouldn't take you that long to think about. So I'll just give you a few seconds. You can write it down and fill in your answer. So on the left side, it says -1/3. On the right side, it says -2/5. So which one of those is the greatest? When you have a question like this, it may be helpful to convert fractions to decimals for those of you who prefer working in decimal form. And because you have an on-screen calculator, it's pretty easy to do that on your calculator. So if you were to divide 1 by 3, you get an approximation for 1/3 that is 0.3. If you were to divide 2 by 5, you get approximation, or you get exactly 0.4. So on the left side, you have -0.3, which repeats. On the right side, you have -0.4. So which one of those two is greater? So obviously, because you're dealing with negatives, the closer you are to 0, the greater you are when you're negative. So if you have a number line, the closer you are to the 0, the greater you are. So what's closest to 0? -0.3 or -0.4?
-0.3.
-0.3, exactly. So this sign should be a greater than sign, right? -0.3 is greater than -0.4. All right, so this is a nice warm-up question, right? Nothing too strenuous here, just knowing how number lines work, knowing how negatives work, and converting fractions into decimals if you prefer decimals to fractions. All right, so let's move on to question number 2. All right, so here's a word problem. I'm going to read it, then I'm going to give you a few minutes to actually try to solve it. It said, this is competency number 1, again, which is knowledge of number sense, concepts, and operations. The question, the regular price of a computer is $1,200, and the regular price of a printer is $300. An electronics store has a promotion that offers a 40% discount on the printer when the computer is purchased at regular price. What is the cost of the computer and the printer at the promotional price. Okay, so take just a few minutes, try that on your own. All right, so the regular price of a computer was $1,200. We can write that down. Computer, $1,200. And it says the regular price of a printer is $300. So printer, $300. And let's go ahead and just write regular price. So we know what those numbers correspond to. It says the store has a promotion that offers a 40% discount on the printer when the computer is purchased at the regular price. So the promotion is a 40% discount on the printer only. So the computer price is not going to change. It's going to stay $1,200. But your printer price is going to be 40% less. Okay? So 40% we can write as a decimal, which is 0.4. So we take the 0.4 and multiply that by the 300, and this will tell us what we save. So this will give us the savings. And if we take 0.6, which is 60%, multiplied by 300, this is get what we have to spend. So you can look at this in two different ways. You can take 40% of 300, that tells you what you're saving, or 60% of 300, that tells you what you're spending. Okay, so it's up to you which way you want to think about it. I like to think about what I'm spending versus what I'm saving. So you can use your calculator to calculate 60%, 0.6 times 300. And that means you're spending $180 on the printer. So you save 40%, you're spending 60%, so you're spending $180. So the question is, what's the total cost of the computer and the printer at the promotional price? We just add these two together. So 1,200 plus 180 is how we get our answer, which is $1,380, which, if you remember, is answer choice B.
Okay, so I have a question.
Go ahead, Kendall.
So about the savings part, like I saw that you did it with the spending. How do you do it with the savings?
Yeah, good question.
Okay.
So if you want to do 40% of 300 on your calculator, that would be 0.4 times 300. That's 120. So this number ends up being 120. That's what you save. So then you would have to do the 300 minus the 120. And that's how you get 180, what you spend.
Okay.
So you have to do an extra step of subtracting. Okay. So if you do the savings, you do a two-step process. You calculate the savings, subtract it from the $300. If you do the spending, you just do it, what you get is what you spend. So you don't have to worry about the second step.
Oh, okay.
That's another reason why I prefer to do the 60% times the cost, because then I don't have to worry about that subtraction step.
Makes sense. Okay.
And see, my issue with that is the connection part of it. When I first did it, of course I did the 0.4. And common sense just told me, well, I know the price isn't 120 because that's more than half of the $300 if I want to buy a printer.
Right.
You know, I know that's not rational, but it didn't connect to me to subtract that 120.
Yeah, that's what I'm saying. It didn't connect me to subtract it either.
And so with harder problems, it gets deep. It's like I get so stuck in the computation part in my mind.
Yeah. So this problem is very real life, right? Because we buy stuff every day, whether it's online or whether it's in person, and we love a good sale, right? We always looking for something on sale. So when you go to, Best Buy, when you go to even Target or Walmart, if something's on sale, you're going to gravitate towards it, right? So when I think about something on sale, I think about, okay, what do I actually need to spend? Not what am I saving, because I need to spend some money. I want to have to spend a certain amount of money. So the savings, yeah, that matters. But I'm more concerned with what does it cost me after I get the discount. So to figure out what it costs you, you look at it as 100% minus that 40%. That 40% is what you're saving. So I want to know what that 60% number is, right? I don't want to know the 40%. I mean, that's important.
Okay.
It's nice to say, oh, I save $120, go me. I save $120. But really, I'm more concerned with what am I spending, which is the $180.
Yes.
Okay, that makes sense.
That does. Okay. Look at it as the whole, that 100%.
Right. Everything's out of 100%. So if you're saving 40%, you're spending the rest of it, 60%. If you're saving 20%, you're spending 80%. If you're saving 25%, you're spending 75%.
That's right.
So it all has to add up to 100.
Okay. Thank you.
All right. Awesome. So now let's go back to we'll go back to the website. So I have to go back and forth between screens. So here's our question. So we just finished this question. We chose 1380. The answer is 1380 is B, so we're correct. So the nice thing about this website is it does give you the correct response. What it does not give you is a breakdown of the solution. Unfortunately, there's no help in understanding if you got the wrong answer, kind of where you went wrong. But that's okay. You can still probably copy and paste this question into Google. Maybe there's somebody else that posted it somewhere out there. Or you can always contact me if you have questions about, anything you see here. All right, so the next one. Which of the following symbols should be placed in the box to form a true statement? So this is very similar to the very first question we did. We have 3.4 and we have 3.309, right? And we can round 3.309 to simply 3.3. So we're comparing 3.4 and 3.3. So we know that 3.4 is greater than 3.3. We don't have any negatives here, so we're not dealing with negatives. So we want to know what's the furthest away from zero, right? On the number line, what's the most number on the number line? So we put this in the number line, 3.4 is to the right of 3.3. So this should be greater than, so choice C is correct. So anytime you have a question like this, think about the number line and where would you place on the number line and what's the number to the most right?
I'm very visual. And even my son is 12. And when he was doing this, and now he's like some math genius and he won't even help me, but whatever. He even told me, draw the number line. I see it better with the number line.
Absolutely. And I didn't show you the number line, but I told you the number line. So we were to, draw that number line.
I saw it even when you said it. I saw it in my head. I'm like, duh, I see it now.
Yeah, always put the 0 right in the middle. And then we had that 3.3 and we have a 3.4. So what's to the most right? 3.4. And even though it was 3.309, we can add 2 zeros here if we wanted to get the same digits. But anyway, 3.4 is the one that's to the most right. So yeah, number lines, and anytime we have a question, it's nice to be able to visualize it. With math, visualizing a question is really, really important. It can make a problem go from like, oh, so difficult to, wow, that wasn't so bad after all, if you have a nice visual. And I'll tell you guys, all this morning before this session, I've been doing SAT. I have my SAT book right here. I've been doing a lot of SAT prep with some high school students. And my biggest thing with them is you have to create a visual. Take these problems, create that visual. If they say a circle has a radius of 5, draw the circle, label it, right in the, create that picture for yourself. If there's no picture already for you, you have to create your own picture.
Okay.
So that's just a really important strategy in general that I, wrong screen, that I like to just make sure that people are doing. Okay, so let's go on to the next question. Question number 4. Students in a mathematics class are allowed to drop their lowest quiz grade. If a student earns the following grades, which grade will be dropped? So we have 6/8, 2/3, 73%, 6/10. So notice you have 3 fractions and 1%. So I like to get everything in the same format, either in a fraction format or in a percent format or in a decimal format. So everything is consistent if you're comparing them to each other. So because we have 73%, I think it's easy to convert all of them to percents or all of them to even decimals. Because if you're working with fractions, you're gonna have to make sure you get the common denominator in order to figure out which one is the lowest. But if you have a calculator and you can quickly convert it to a decimal, it's much easier to see. Okay, so let me go back to my other screen and I'll write down these same numbers that we're given. So we're given 6/8, 2/3, 73%, and 6/10. So on your calculator, we can write all of these in decimals. So 73% we know is 0.73. 6/10 we know is 6/10, so that's 0.6. So the other ones we may need a calculator to figure out. So 6/8 on a calculator is 0.75, and 2/3 on a calculator is 0.6 repeating.
So we have to put that repeating up there because every little thing, I think they try to trick me. Why would they put that repeating in there?
Right, because it's really 0.6666, right? Goes on forever. So yeah, 6 repeating. So the question is, what's the lowest, right? We want to drop the lowest grade. So obviously, we don't want to drop the 0.75 or the 0.73. Those are the 2 highest. So what's the lowest between 2/3 and 6/10? So that's why the repeating does matter, because 0.66 is greater than 0.60. So the lowest will be the 0.60.
Yeah, rather have a 66% than a 60%.
Right.
Makes sense.
So I think converting these to decimals, it provides a visual. It helps us to line up the decimals and see which one is the greatest and see which one's the least, and we can drop that lowest score. Jashonda, thank you for joining us. If you have pencil and paper, you can also follow along as we work through some sample questions from the GK math section. All right, so let me go back to our test. And so we finished this question. We chose 6/10, and we can check our answer. It is the correct response, so we're good. All right, next question. All right, you have another word problem here. An electronics store has a current inventory of 50 stereo systems. The lowest price stereo system in the store sells for $800. All right. The highest price stereo system sells for $3,000. So our range is 800 is the lowest, up to 3,000 is the highest. And it's we have some things in the middle that are not provided. Which of the following is the maximum amount of $3,000 systems on hand if the current inventory totals $111,000? Okay, so I'm gonna just pause and let you all reread that. Write it down, write down your key information, think through it, and then I'll go back to my other screen and we'll work through it together. But first, just take a few minutes and kind of digest it. All right, so I'm gonna go ahead and change my screen and go to my whiteboard. Okay, so we have the lowest price stereo system. And we have the highest price stereo system. And they give us the highest price. And write down highest priced. The lowest price they told us is $300 or $800. And the highest priced is $3,000. All right. And we want to find out, and we have a total of 50 stereo systems in our inventory. So the inventory, we need that, of 50 stereo systems. And it's asking for which of the following is the maximum amount of $3,000 system. So we want to maximize the number of stereo systems that are worth $3,000. And it says the current inventory totals $111,000. So inventory, there's 50 stereo systems valued at $111,000. Okay. So any thoughts or about this before I kind of proceed from any of you that are with us live? Anybody have any thoughts or suggestions about how we should approach this?
You don't divide 3,000 and 111,000, do you?
Divide 3,000 into 111,000?
Yeah.
You can, yeah.
But that won't work though.
So I want to show you sort of I think we should kind of build a table because I think that, again, visuals help. So what we do know though is that we have 3,000 times some number of stereo systems. We don't know what that number is. We can just call it X. Plus 800 times Y. We don't know what that number Y is. And again, we have other stereo systems too that are in between. So we could have plus, some other price times Z. We have other things in here too. But we know that the stereo systems are valued at $111,000. And we want to maximize the value for X. What's the largest value for X we can have to make this equation true? So the nice thing about this test is that they give you answer choices, right? So you notice the answer choices, A was 30, B is 32, C is 35, and D is 37. So because we're trying to find the maximum value, we can start with choice D, because that's the maximum value on the list, and see if that works. So this is a very important test taking strategy of using your answer choices and kind of working backwards. So if the number of stereo systems that cost $3,000 is 37, what does that give us? We'll have 3,000 times 37. So what is that number? So let's get our calculators out. 3,000 times 37. That's exactly 111,000, right? So we know that number is too big because that means we don't have any other stereo systems but just that one type. And the question says that we have different types of stereo systems, not just that one type. So that would mean our entire inventory would be the $3,000 stereo system. So we know it's not 37. That's too big. So we can eliminate choice D. So now let's look at choice C, which is the second largest, the 35. Okay, so if our X was 35, then we would have 3,000 times 35, which on your calculator works out to be $105,000. Okay, so that's for the most expensive stereo system. So why, let's say we didn't have any other stereo systems. We just have the two different types. The highest price is 3,000. The lowest price is 800, right? So we're going with our very lowest price, which is 800. So in total, we had 50 stereo systems. So Y would be 50 minus 35. So we have 15 that could be valued at the lowest possible. And if all 15 are $800, which is the lowest price, that's $12,000. So if you added up $105,000 to $12,000, you're going to get a number that is too big as well. 117,000 is over our inventory number of 111,000. Okay, and we made all of the remaining stereo systems, the 15 remaining, we made them at the lowest possible price. The $800 is the lowest possible price. And you still got a number that was too big. So that's not going to work either because we're over the inventory value. So 35 is also too big. We can eliminate choice C. Okay, so now let's look at choice B, 32. So let me erase this. And now we're going to make X be 32. And we're going to see what happens there. Okay, so if our X is 32, we have 32 stereo systems priced at 3,000. So 3,000 times 32 gives us $96,000 of inventory. And if our Y is 50 minus 32, because there's 50 total, that means we have 18 we can make it the lowest possible price. So all 18 remaining stereos are $800. That is $14,400. If we add these two together, we get $110,400, which is less than our inventory, which means this is a possibility. Because remember, we have other price points between these two. We just have the lowest and the highest. So we still have extra inventory or extra money or extra value that we can associate with other stereo systems. But this means that we can have 32 of the highest priced stereo systems. That's the maximum we can have in order to get to that inventory value at 111,000. So B would be our answer for this. 32 is our max. 37 was too big. 35 was too big. 32 is the largest of the rest of the answer choices. So sometimes it's very helpful to use your answer choices to actually get to your correct answer versus, that's called the back solving approach. We back solve, we use our choices, we plug them into the question, we see which one works out. It takes you a lot less time to back solve. And we got a time test here, so we want to do the quickest possible approach. And oftentimes that's picking numbers or back solving, which I'll show you examples of picking numbers if we have time. But this is a really good example of how to back solve a question, using your choices, plugging them in, seeing which one works.
Now, this model you gave, when you wrote it out, that wouldn't have been my first choice to do. You know, the 3000x plus 800y plus we don't know t equals 1100,000. I wouldn't have thought, yeah, you made it so much simpler.
Yeah, because when you think about money, right? So money is something we all think about every day, right? We always think about money. When we're ordering pizza, we're thinking about money because toppings cost additional amounts of money, right? Yes. So this is something we think about all the time, whether we know it or not. So yeah, I think about, okay, to get to $11,000 in inventory, I have so many of these units that cost $3,000. I have so many of these units that cost $800. And I have so many of these units that cost some other amount of money, I don't know. For completeness, I included this blank because we don't know the cost. And then Z is the number of units we have. But we don't even know how many total stereo systems we have. We could have 10 different types of systems or 100 different types of systems. We don't know. But it doesn't matter because we're using our lowest and our highest to arrive at what's possible. So we don't really need to know how many units we have or different types of units that we have and the other price points. That's not really the purpose of this problem. It's really just to identify what's possible and what's not possible. So this was just more for completeness, but you could really erase this part and then you could make sure that this 11,000 number is less than or equal to. Less than or equal to is maybe a better way to think about it, or another way to think about it, because when you take 3,000 times the number of units that are the highest price, and then 800 times the number of units that are lowest price, you want to make sure that that total is either equal to 111,000 or is less than 111,000, because of course we can have some other systems in there to make up for the difference.
Understand. Thank you.
All right. All right, let's go back to our test. I have too many screens open. Okay, so this is the one. Here we go. Okay. So we chose 32. Correct answer is 32. Good. All right, next question. All right, here's a expression that we need to simplify. So 15 minus 3 in parentheses divided by 2 plus 1 in parentheses times 8 minus 6 in parentheses. So take a minute and write that down. And here it's important to use order of operations, which we tend to call PEMDAS, right? Please excuse my dear Aunt Sally. Parentheses, exponents, that's the P, that's the E. The M is multiplication, D is division, A is addition, S subtraction. Please excuse my dear Aunt Sally is the way that I remember it being taught in middle school. So if you have that written down, you can work through that as I go back to the whiteboard. And I'll write it on the screen here. So it's 15 minus 3 divided by 2 plus 1 times 8 minus 6. So what do you all think is our first step here?
Parentheses.
Absolutely. So work through what's in the parentheses, because when we think about PEMDAS, PMDAS, we always start with the P, which is the parentheses. So what is 15 minus 3?
12,
12 divided by, what is 2 plus 1?
3,
3 times, what is 8 minus 6?
2.
2. Awesome. So next, exponents. We don't have any exponents. We can cross that out. And then multiplication and division, this really should be in the parentheses because whichever one comes first. So in this case, we see division first. So we're going to do division first. So what is 12 divided by 3?
4.
4. Carry down the times 2. And then we do our multiplication next. So what's 4 times 2?
8.
8. So 8 is our answer. And if we had addition subtraction, it'll be whatever comes first there.
Makes sense.
So 8. All right, go back to our test. And we choose 8, and it is 8, correct. All right, next one. Okay, a building 51 feet tall casts a shadow 48 feet long. Simultaneously, a nearby statue casts a shadow 16 feet long. How tall is the statue? Take a few minutes, think about it. And I'm going to go ahead to the whiteboard. Okay. So again, I love visuals. So a building 51 feet tall. So I'm going to represent, this is a building. It's 51 feet tall. And it has a shadow. We know the shadow is always kind of like the slant of the building. So it's like, this is the building. I'll put that kind of represented with this jagged line. And then here's our shadow. So what we're doing is really creating triangles here. The shadow is 48 feet long. And actually, I'm going to erase this. And then we have, because this shadow doesn't go all the way down to the ground. The shadow is not as long as the building. So if I were to draw a more accurate picture, I would do something more like this, where it doesn't go all the way down. And then we have a nearby statue that has a shadow of 16 feet. So I'm going to do that in green. So we have a statue. We can represent that with this jagged line as well. We don't know how tall the statue is. Its shadow is 16 feet. Okay, so basically these are similar. We could do that if we want to make a triangle, but they're similar triangles, they're similar shapes. We have one vertical, and then we have a slant, and they tell us how long the slant is. And so we can use proportions to figure out how tall the statue is. Now, if I was writing this question, I would want to be absolutely sure that the test taker knew that they were similar in shape. Maybe that's getting a little bit too technical, but the 51 is the height of the building. It corresponds to some unknown height of the statue. And the shadow of the building is 48. It corresponds to the 16 feet shadow for the statue. So our proportion would be 51 corresponds to X, and 48 corresponds to 16. That's one way to write it. Or you can do the opposite. X corresponds to 51, and 16 corresponds to 48. Or you can do 51 corresponds to 48. So stay on the same side, and X corresponds to 16. So all of these proportions are identical to each other. It's just, it's your choice in how you want to write it. You'll end up getting the same answer for X regardless of which way you wrote it. So 3 different ways to write it. I tend to, go with one that has X in the numerator versus denominator, but it doesn't matter because in every proportion, you're going to cross multiply and solve it. So if we cross multiplied and solve this, we'll get 48 times X equals 51 times 16. So we need our calculator here. 51 times 16 is 816. So 48 times X equals 816. And then we're going to divide by 48. And so we can find the value for X, which is the height of that statue, is 816 divided by 48. I end up getting 17 feet. Okay, so we go back to our test. 17 feet. There we go. So that's just a matter of setting a proportion. The height for the statue corresponds to the height of the building, and the 2 shadows correspond as well. Any questions there?
No.
Okay. Next question, question 8. Now we've moved on to competency 2. Let's see, the previous question was also competency 2, which is knowledge of geometry and measurement. I think it's good to take a look at what competencies the questions relate to so you can understand where your strengths are, where your weaknesses are, what you need to focus more on. So we just finished an example of competency 2, which is about geometry. And now we're going to look at another example. So this one says a rectangular animal pen will be built using 200 meters of fencing. If one side of the rectangle is 60 meters, find the area of the pen. Okay, so whenever you have a geometry question, making that visual, drawing a diagram is really important. It's important for really every question. But they give you a rectangular shape, so you definitely want to draw a rectangle, and you definitely want to label your rectangle as well. So I'll give you just a few minutes to try this question, and then I'll go to my whiteboard. All right. let's see what we have here. All right, so we got that rectangular pen. So here's my rectangle. We know a rectangle has 4 right angles. And it says we built using 200 meters of fencing. So we know a rectangle has a length and a width. So we always want to label the size, length and width. And we know that the total number of fencing, the fencing is basically the same as perimeter, because when you go around with fencing, that's called a perimeter. So perimeter equals 200 meters. Okay. So going around this rectangular pen, there's 200 meters of fencing. So if we were to add up all the sides, that's the definition of perimeter, P for perimeter. Adding up all the sides, we get W plus L plus W plus L is 200, which we can just say 2L plus 2W equals 200. And it says if one side of the rectangle is 60 meters, find the area of the pen. So one side, it didn't say which side, so we can choose whatever we want. So we'd say choose the W to be 60. So that gives us 2L plus 120. We plug in the 60 equals 200. And then we can solve this. Subtract 120 on both sides. So we know that 2L equals 80. And divide by 2 on both sides gives us the value for L, which is 40. So that means our width is 60 and our length is 40. And they asked us for the area, which is always for a rectangle, L times W, length times width. So area equals 60 times 40. We know 6 times 4 is 24. We add 2 zeros. So 2,400, and this is in, I believe it was in meters squared, or square meters. Does anybody have any real-time questions about this one?
No, I did it all wrong.
What did you do? You want to share what you did?
I made my rectangle. I put the 60 meters on one side because it just said one side. And I'm thinking, I thought it said find the area. So maybe I didn't even.
No, it did. It did say find the area, because that's what we end up doing over here. We did find the area.
Well, what I did was I just multiplied 60 times 4. I thought it was 60 plus 60 plus 60 plus 60.
Oh, no. So like you just said, it said one side is 60, right? But we didn't know the other side. So you didn't use the perimeter at all? Did you use the 200 meters at all?
I didn't even use the 200 meters at all.
Okay. So most times if they give you information like that, it's because you need it, right? I don't think you have to worry about them giving you information just to try to throw you off.
Okay.
This test, I think, is about giving you what you need to solve versus giving you more than what you need. So if they give you the perimeter is 200, then you more than likely, or you can almost guarantee that you're going to need to use that number to solve. So if you're not using all the information, you're probably making some kind of mistake. But we needed the 200, the perimeter, in order to solve for the other side, right? All the sides weren't 60.
Right.
So we knew that we had 2 sides equaling 60, right? The parallel sides. But the other pair of sides, we did not know what the measure was. So that's why we had to use the perimeter to find that missing side. Then we could do the area.
Understood.
Okay. Okay, let's go back to our test. And I'm going to choose, I'll kind of skip around just a little bit, just show you more variation. So here is a three-dimensional triangular prism. And it says, which of the following best describes the faces for the following figure, the faces. So we have this triangle. Our base is a rectangle. And then we have a triangle on the two opposite sides. And then if you look at the bottom, this is what you need to figure out. So if we just take this apart, take this diagram apart, hopefully the first thing you notice is the triangle, because it has 45 degrees, 45 degrees. And we know that the other angle there has to be 90 degrees. So that means we have a 45, 45, 90 triangle. So anytime you have a triangle where two sides are the same and two angles are the same, that's called isosceles. So you have to know the definition of isosceles. Isosceles means two sides of the triangle are the same and the two opposite angles are the same. So if I cannot write on this is not my screen, but this angle between this third angle and the triangle would be 90 degrees, and that would create an isosceles triangle. Equilateral, on the other hand, means that all three angles are the same and all three sides are the same. So we definitely don't have equilateral, because equilateral, if all three angles are the same, and you know the total number of angles, the total, the sum of the angles in a triangle is 180. So if you add up all three sides, you would get 180. If it was equilateral, each of those angles would be the same, which is 60. 60 plus 60 plus 60 is 180. So we don't have equilateral because they're not all 60. So we can eliminate choice A and B. Because A and B have two equilateral triangles, and that's not what we have. We have two isosceles triangles. Because we see those two equal angles, two equal sides. Okay, so now the question is, if it's C or D, do we have one square and two rectangles, or do we have two rectangles and one square? So we see the rectangle that's facing us, that's labeled C by A. We know that's definitely a rectangle because C and A are different variables. So we know we have that one rectangle. Now we have parts of this diagram that we cannot see. We cannot see the bottom, right? We cannot see the back. We cannot see the opposite side of that triangle, but we know the opposite side of the triangle is another triangle. So really we're focusing on the bottom and the back. So you notice the bottom, it has an A and it has another A. So A by A means that the sides are the same. If the sides are the same, it's a square. If the sides are not the same, it's a rectangle. If it's a four-sided, in this case with four sides. We have A by A, and because we know that A and B are equal, because A and B are, we have the isosceles triangle. So let me just go to my other screen so I can show you a diagram. So we have this right triangle that's isosceles, 45, 45, and this is 90, and these two sides are the same. This is the definition of isosceles. And this was labeled, this one was labeled B, and this one was labeled A. But because it's isosceles, these are actually the same measure. So basically A equals B. And that's really the key takeaway, the key learning here, that A equals B. So if A equals B, you know that these two, we can just take away the B and we can just put an A so that we remember that they're equal. So that way you know that bottom side that we really can't see and that back side are both going to be A by A, which gives us the squares, not rectangles. So let's go back to the question. So that A by A at the bottom here, A by A, that's a rectangle. I'm sorry, that's a square. And then the back side is A by A, because remember A equals B. So that's another square. So the answer should be D. We have two isosceles triangles. We have two squares, the bottom and the back, and then we have one rectangle, which is that front side, the slant, the ramp that we're looking at. So we choose choice D. Okay, does anybody have a question about that one? Okay. So another example from Competency 2 about geometry and measurement. All right, so let's go on to the next one. Another one from Competency 2. Which of the following is the best estimate for the height of a kitchen refrigerator? So this is not, you're not expected to go and measure your refrigerator or even know exactly what the height of your refrigerator is, but you are expected to know the difference between kilometers, meters, centimeters, and millimeters. So in general, a millimeter is the smallest of the four, right? That's something like the measurement of your fingernail. You can measure that in millimeters, or you know, something a small amount. If you want to measure an ant, for example, an ant you can measure in millimeters. Centimeters is larger. You can measure this ink pen in centimeters, for example. You can measure your cell phone in centimeters. Meters is what you would think about if you're going to measure a refrigerator, right? Centimeters is too small. So you want to think about meters, which is 1 meter is 1,000, right? Meter means 1,000, centi means 100. So if I was going to measure my refrigerator, I would need a meter stick, or I would need, you know, something bigger than centimeters. And then of course, kilometers, that's way too big. That's something that you would measure for longer distances. Like if you're going to run around the neighborhood, you could run, instead of miles, you could measure in kilometers or kilometers. So hopefully you didn't have trouble with this one, knowing that it was meters versus the other choices here. All right. Similar question about the height of a mountain. So now we need something bigger than meters. We need kilometers for the height of a mountain. Okay, here's one. How many square yards of carpet are needed to completely cover a rectangular floor that measures 15 by 9 feet? 15 feet by 9 feet. So notice there's going to be some unit conversions here, because you have square yards of carpet, yards, and you want to cover a floor that's measured in feet. So you're going to have to convert here. So I'll give you a few minutes and kind of think through this one. And if you have forgotten, 1 yard equals 3 feet. So that's the conversion you need. 1 yard is equivalent to 3 feet. And that's one of the pieces of information they give you on that reference sheet. So if you forgot that on your real test, you have that reference sheet. You can look it up. Jashonda or Kendall, do you have an answer for this one?
I got 45.
You got 45?
Yeah.
Okay, Jashonda, did you get anything?
Yeah, I did the same thing. I was confused if we were supposed to just look at the 15 feet or the 9 feet as well.
You definitely need both, because you're trying to cover the entire floor with carpet. So you need both the length and the width of the floor. So think about your own home, right? Or your living room. You have a length and you have a width, and you want carpet over the entire area. So I'll go to my whiteboard so I can show you. Hopefully you both drew a rectangle. Yeah?
Yeah.
Okay, good. And then you labels your rectangle. So here's our room. And it measures 15 feet by 9 feet. 15 feet by 9 feet. And this is what we want to cover with carpet. We're replacing the carpet. So we need to know how much carpet we need to replace. But the key is that we have to convert to yards. We know 3 feet is 1 yard. So we have 15 feet. We know there's 3 feet in 1 yard. How many yards is that? Kendall or Jashonda, how many yards would that be?
5.
It'd be 5 yards. So instead of 15 feet, we can cross this out and put 5 yards. And if we have 9 feet, what is that in yards?
3.
3 yards. So what's the area of this region in yards?
15.
15. And that's it.
Oh.
So Kendall, was your mistake when you were converting from feet to yards, or where did you make your mistake?
Yeah, I think I didn't convert it, I don't think. Well,
Okay.
hold on. Cause I did 15 times 9, which got me 135, and I divided by 3.
Oh,
So
see,
you
your
try to
mistake
convert
was
to
you should have
yards.
divided by 9, not 3. Because
Oh,
if you had 15 times 9, which you said was what?
135.
135.
Yeah.
This is in feet squared or square feet. So you need to convert square feet to square yards. So if 1 yard equals 3 feet, then if you square both sides, 1 square yard equals 9 square feet.
That makes a lot more sense now.
So you have to take this and you have to divide by 9, not by 3. So 9 square feet is 1 square yard. So 135 divided by 9 should give you what?
15.
15.
Okay.
So we did our conversion before we multiplied. You did your conversion after you multiplied.
Yeah.
So if you do it after you multiply, make sure you have square yards, not just yards.
Okay.
Okay. Let me go back to the question. All right, so here we have another volume. We have a, looks like a house here. So it says a building contractor needs to compute the volume of air conditioning or air contained in a building with a rectangular floor as shown in the figure below. The building is 20 feet long, 4 yards wide, 9.5 feet high on 2 sides, and 15 feet high from the floor to the peak. What is the volume of the air in this building in cubic feet? So again, we have to worry about units here because we're given some units in feet and we're given some units in yards. Our answer choices are in feet and cubic feet. So we need to convert that yards number into feet so that everything is in feet versus having 2 different units. All right, so take a few minutes and think through this one. And I'll give you a little hint. Because the bottom part looks like a rectangular prism and the top part is more triangular, a triangular prism, you can separate those 2 pieces. Find the volume of the rectangular prism first, find the volume of the triangular prism second, and then you can just add them back together. So it's like the roof of the house. Go ahead and remove the roof and consider that a separate, consider that separately from the rectangular prism part. So you're going to use two different equations, one for rectangular prism, one for triangular prism, and then you're going to add them back together.
Can you go back to the picture for a second?
Sure.
Okay, you can change it.
Okay. I'm doing my best attempt at drawing these two, the rectangular base and the triangular top. So they tell us the rectangular base is 4 yards, 4 yards long or wide, and then 20 feet long. And we're going to talk about this height part in a minute. It tells us it's 9.5, 9.5 feet high. And then you have the triangular part. This one, not so good at drawing. All right, so something like that. All right, so the first thing we need to do is make sure that our units are the same. So we have feet, feet, and yards. So we got to do our conversion. So 4 yards, our conversion is that 1 yard is 3 feet. Yards cancels out. So 4 times 3 is 12. So 12 feet. So instead of the 4 yards, we're going to cross that out and put 12 feet. So everything's in feet. So the volume of this rectangular prism is length times width times height. So that's 9.5 times 20 times 12. And if you do that on your calculator,
2280.
thank you, 2280, and that's in cubic feet. Okay, so that's one part. Now we can do the triangular part. So we know that the length is still 20 feet. We know that the width is still 4 yards, which is 12 feet. Now the height here, if you go back to the diagram, remember the full height was 15. The full height was 15. Let me go back to the diagram so you can see. So the full height from the very top of the roof to the very bottom is 15. And just the rectangular part is 9.5. So the difference between 15 and 9.5 is from the top of the rectangle to the bottom of the rectangle. So 15 minus 9.5 is what?
5.5.
5.5.
Yeah, so that's what we want for the height of our triangular, for the triangle. So 15 minus 9.5, 5.5 feet. So the volume for the rectangular prism is 1/2 base times height, that's from the triangle, times really the height or the length, whatever you want to call it, of the full diagram. So normally it's called like big H. You have little h, that's for the actual triangle, and then big H is like the height of the entire prism. So 1/2, the base is 12, the height is 5.5, and then the big height will be the 20. That's how tall the actual prism is. So if you do this on your calculator, what do you get? 1/2 of 12 is 6. 6 times 20 is 120, times 5.5 is 660. And that's cubic feet. So you add the two together, add the 660 to the 2280, and you get your grand total. For the volume, I'll put total, which is 2,940 cubic feet.
I'm sorry, wouldn't the big height be 15?
No, it's this 20 right here. Let me circle it in purple. This is
Okay.
that's how tall that that triangular prism is.
Okay.
So this 12 is 5.5, and that is the height or the length, however you look at it, of the triangular prism. So we go back. We see our answer here, 2940, which is choice C. And yes, correct. So I think the really important tip here is to make sure you take the diagram kind of apart and look at it as two separate shapes versus this one big shape. Find the volume of the two individual shapes and add those two volumes together. And of course, make sure that you do all your unit conversions so that way, you know, you're not messing up units. And Kendall, as I said before, it's better, I think, to convert before you multiply than after you multiply. So we converted 4 yards to 12 feet initially, so we don't have to worry about converting in the end. Okay. Next question. Competency number 3, knowledge of algebraic thinking and the coordinate plane. So this is an inequality. Which of the following is a solution of the inequality? So we have this inequality. -3 is less than 2x plus 1 is less than 5. And then we have 4 answer choices. So I'll give you guys just a minute to write that inequality down and try to solve it. Did you guys solve it okay, or how did you do on this one?
I'm not sure where to start.
Okay. All right, so that's our inequality. So whenever you have a double inequality, I like to separate it into two separate inequalities. So the first inequality will be -3 is less than 2x plus 1. And the second will be 2x plus 1 is less than 5. So do you understand, Jashenda, why and how I was able to separate the inequalities?
Yeah.
Okay, and then I think it makes it a lot easier at this point because you can solve them both separately. So to solve, you subtract 1 on both sides. So you have -4 is less than 2x. And then you divide by 2. And so the 2's cancel. You have -2 is less than x. And then on the other side, subtract 1. And you have 2x is less than 4. And divide by 2. And you have x is less than 2. So if we were to graph this, I think it's helpful if you see it on the number line. So if we were to graph this, here's our 0. And then we have 2 and we have -2. So x is less than 2. So less than 2, but greater than -2. So anything in between -2 and 2 is a solution. And notice that these are open circles, not closed circles, because it's not equal to, is greater than or less than. See, these circles are open. So anything between, so -1 is the solution, +1 is the solution, 0 is the solution, and of course, all the decimals and fractions in between the two. Was not a solution is -2. Was not a solution is +2, or anything on these ends. So this is not a solution, and this is not a solution.
Can't you just plug in the answers to where x is and then
Absolutely.
you
And also plug in. Yeah.
Just make sure it's true. All right, makes sense.
Yeah. So if I go back to the test, if you choose to plug in, you will plug in, -2 first. You see that does not work. Then plug in 0. That does work. That's your answer. Plug in 2. That does not work. And plug in 4. That does not work. So yes, you can either solve it algebraically, or you could take the answer choices and plug them in, see which one works. So what you just described, Kendall, is that's our back solve strategy. We go backwards by taking the answers and plugging them in. That's working backwards or back solving. All right, here's another algebraic expression or equation. You can do the same thing, Kendall. You can take these answer choices and plug them in, or you can solve it algebraically. The more complex they are, sometimes it's easier to solve it algebraically. Sometimes it's easier to back solve. You kind of have a decision to make on how you want to approach it. I'm going to show you how to solve it algebraically, but for the purpose of your test, you can choose whatever method you prefer. So take a few minutes and solve that equation. I'll go ahead and write it up on the whiteboard so it's a little bigger for you to see. So we have 4x minus 1 divided by 5 equals 2x plus 1. And there's no denominator, so I always like to say divide by 1. If there's no denominator, just know there's always a 1 there. I'll give you all a minute or so to solve that equation. Okay, so you can solve this. I like to cross multiply when I see fractions like this. Or you can simply, which is the same thing, you can simply multiply both sides by 5 to get rid of the 5. So you multiply this by 5, you multiply the other side by 5 as well, and the 5s cancel on the left side. So that way you don't have your denominator anymore. You just have 4x minus 1 equals 5 times 2x plus 1. Notice I just moved the 5 in the front. Distribute the 5 in the parentheses. 4x minus 1 equals 10x plus 5. Combine like terms, so subtract the 4x from the 10x. So negative 1 equals 6x plus 5. Subtract the 5 to the other side. Negative 6 equals 6x, and divide by 6. And then you'll find out that x equals negative 1. Any questions there? Okay. Let's go back to the test. And we chose negative 1, and correct response is negative 1. All right, the next one, another algebra question. Find an algebraic expression that's equivalent to this expression, which says 3/2 times 6x squared minus 2/3 x. 3/2 times 6x squared minus 2/3 x. So I'm going to write it on my whiteboard. Three halves times 6x squared minus 2/3 x. Okay. If we distribute the 3/2 inside the parentheses, what do we get? We're going to write this out first, and then we can do the math. So we get 3/2 times 6x squared minus 3/2 times 2/3 x. So our first step was just to distribute the 3/2 inside the parentheses. So now let's do the math. So 3/2 times 6. We can divide 2 into 6 first, and that gives us 3. And 3 times 3 is 9. So that's 9x squared minus. And now we do the 3/2 times 2/3. Well, that just cancels out. 3's cancels, 2's cancels. So now we just have the x left over. So 9x squared minus x. Is that what you guys got?
Yes.
Awesome. Okay, we go back and we chose B and we're good with that. Okay, so it says a student argues that 4 times the quantity x minus 5 minus 6x plus 1 equals negative 2x minus 19. Identify the first step that contains an error. So identify, I'm making this bigger here. Identify the first step that contains an error. Is it step 1, 2, 3, or 4? So study that and try to figure out where the mistake is. And let me know when you all feel like you have you figure out the mistake. Kendall, you got it?
It's not step 1, is it?
Well, you tell me, do you see a mistake in step 1?
Would it be in either step 2 or step 3? Because they didn't distribute the negative.
They did not distribute the negative correctly. You're right. So when you distribute the negative, you distribute it to not just a 6x, but also to the 1, right? So it should be, in step 2, it should be 4x minus 20. That's correct. Negative 6x is correct, but this plus 1 at the end is not correct. That negative out front here must be distributed inside the entire parenthesis. So it should be a negative 6x minus 1 negative 6x minus 1 or minus 6x minus 1. So step 2 is where the first mistake happens. Kendall, you see that? So step 1 was distributing the 4 inside the parentheses. So 4x minus 20 is correct. Step 2 was distributing the negative 1 inside the parentheses, and that's where the mistake happens. So we're going to choose step 2, and that is correct. All right, any questions? Shanda, Kendall? Okay, let's look at the next one. Find an algebraic expression equivalent to y over x plus 3 over 2y. Y over x plus 3 over 2y. So does anybody know our first step here?
Do you cross multiply?
No, but I'm so happy you said that because that's a really good point. You cross multiply, Shanda, if there was an equal sign. So if I erase this plus sign, and if I put instead in its place an equal sign, then you will absolutely be correct that you cross multiply. But there was not an equal sign there. There was a plus sign. So when you have a plus sign, you do not cross multiply. You only cross multiply across an equal sign. So we have a plus sign. What do you need to do first? Does anybody know?
You multiply.
Starts with a C. Common what?
Denominator.
Yes.
So do you flip the first one?
What's that?
Do you flip the first one, the y over x? Is it the keep, change, flip it?
No, keep, change, flip is when you're dividing with two fractions. That's okay. So if you have, for example, I'll give you an example of that. If you have 3 over 5 divided by 4 over 3, you would keep, you would change, and you would flip. But again, that's when you have division. We have division. So we're not going to do that for this question. For this question, we're adding. We're not dividing, we're adding. So we don't keep, change, flip. But we do need a common denominator. Whenever we add or subtract, whenever we add and subtract fractions, we need common denominator. So we have an x, but we don't have a 2 and we don't have a y. We need to multiply by 2y over 2y. And on the other side, we have a 2y, but we don't have an x. We need to multiply by x over x. So now this becomes 2y squared over 2xy plus 3x over 2xy. So now our denominator is the same, 2xy, so we can combine the numerators, 2y squared plus 3x. And that is our answer. So if I go back, we look at our answer choices, and we choose choice D, 2y squared plus 3x over 2xy. So a summary of that, when you're adding fractions or subtracting fractions, you need a common denominator. When you're dividing fractions, you keep, change, flip. When you have a fraction equaling another fraction, you cross multiply. All right. All right, let's take a look at this one. A consumer makes a down payment of $250 and plans to pay $60 per month for a phone service. So $250 is the flat rate, and then $60 every month. And M is the number of months. So you want to know what's the total amount that you pay. So again, this should be pretty real life because we all have cell phones. We all, pay monthly amounts. The monthly amount could be the same every month. It could vary every month. But if it's the same every month, then that's exactly what this represents. You pay a flat fee up top to get the phone, and then you have a monthly fee every month. So the T is the total amount of money you pay. So does anybody know which equation we would use to find the total amount?
B.
B is correct because the total amount equals 60 times the number of months plus the $250 down payment. I have no idea where this 190 came from, but B is correct. Awesome. So that's a linear equation. Okay, here's another inequality. So in this case, we only have one inequality, so we don't have to worry about separating them out. We can just combine our like terms. So go ahead and try that. Combine like terms. And tell me what you get.
Is it C?
It is C. Good job.
All right, cool.
Shanda, you got that?
Yes.
Awesome. And then we will move on. Another inequality. Same thing, combine like terms. Tell me what you get.
Is it B?
Let's see. It's A. So let's talk about this one. I have a feeling I know what you did wrong. So we have 10C plus 5 is less than 4C minus 1. So what was your first step?
Add 1 to both sides.
Okay, and if you add 1, then you're gonna have to move the 10C to the other side. So I'm gonna do that, but I would recommend moving the 4C to the other side, not the 1. And I'll tell you why in a second. So here we have 6C plus 5 is less than -1, and then we subtract the 5 to the other side. And we have 6C is less than -6, and divide by 6. We have C is less than -1. So that's A. Now, if you do it the way you did it, so let me write the question again. So if you, instead of subtracting 4C, subtracted 5 to this, no, sorry, you added 1. So now you have 10C plus 6 is less than 4C. And then you subtracted 10C, right?
Yeah.
So you have 6 is less than -6C. So here is where the big difference comes from. In the first time we did it, when we divided both sides, we divided by 6, right? To cancel out our coefficient. Now what are we dividing by?
-6.
-6. And whenever you divide by a negative, Jashanda, this is what you need to remember. Whenever you divide by a negative, you flip the sign. So now we flip our sign, and we have -1 is greater than C. which is the same thing that this says. -1 is greater than C, which is choice A. So whenever you divide or multiply by a negative and you have an inequality, you must remember to flip your sign. So that's why I would have kept it positive, so I wouldn't have to worry about that. Versus the way you did it is now you're dividing by a negative coefficient, not a positive coefficient. So you have to flip it. Okay?
Okay.
All right. Next question. Another inequality. I'm going to skip through some of the inequalities. Here we go. Let's do this one. Algebraic thinking. Which of the following equations can be used to find the number of gallons a 50% alcohol solution, X, that should be mixed with 10 gallons of a 35% solution in order to get a 40% solution? So the nice thing here is that we don't actually have to solve for X. We just want to set up the equation. You don't really have to do the math and solving it. This is actually a question I've seen on the SAT, as well as the GMAT and the GRE, in which case you will actually have to solve it. So here we just want to set it up. And setting it up is the hardest part. Once you have it set up, then you can solve it pretty quickly. But it's the setup that really gets everybody. So which of the following equations can be used to find the number of gallons of a 50% solution, X, that should be mixed with 10 gallons of a 35% solution in order to get a 40% solution? I'm going to go back to my other screen. And I like to represent information like this in a table just to make it easier. So we have percent solution. We have number of gallons. So it says a 50% solution. So that's 0.5. And we will have X gallons of that mixed with 10 gallons of a 35% solution. So you're mixing these two together. When you mix them together, now you have X plus 10 gallons. So you simply add the number of gallons together. And the percentage solution you now have is 40%. So you do not combine the percentages together. You combine the gallons together, X plus 10, and they told you that makes a 40% solution. So your equation will come straight from this table, which is 0.5x plus 0.35 times 10 equals 0.4 times x plus 10. Does that make sense to everybody?
Yeah, you made that look too easy though.
Well, I mean, I wouldn't say, it kind of is, but you have to set it up correctly. I mean, it's all about the setup.
Yeah.
And then they want you to do this math here. Go ahead and multiply that. So that gives you 0.5x plus 3.5, oops, not equals, plus, undo, plus 3.5 equals 0.4x plus 10. So the tricky part, I think, is this part. The total number of gallons is the combination of what you're combining. You have X gallons that you put in, and then you add another 10 gallons. So now you have X plus 10 gallons in this big container. So this is our equation we would use to solve. And we see that it's one of our answer choices, so that's great. Answer choice C. 0.5x plus 3.5 equals 0.4 times x plus 10. Like I said, the x plus 10, I think, is what people generally miss. And that's, you know, the total number of gallons when you combine them together. All right. All right, which graph represents a function? So you have to know the definition of function here. There's something called a vertical line test. Who's heard of the vertical line test before?
I've heard of it, but I don't remember what it means.
So if you draw a vertical line and you only intersect one point, that's considered a function. But if you draw a vertical line and you intersect more than one point, it's not considered a function. So if you took answer choice A and drew a vertical line down, which I can't really draw on the screen here, but you would intersect 2 points, right? So that would not be considered a function, because you would intersect a point from this top and a point from the bottom. So that would be that intersection, you would intersect 2 points. If you drew a line straight down in choice B, you will not intersect 2 points. No matter what kind of vertical line you drew, you will only intersect 1 point, because the way that it's shaped is not, you cannot intersect 2 points by a vertical line. So that is the answer. B is the one that's a function. Choice C, if you drew a line straight down, you will intersect 2 points. You could intersect 2 points because it's a circle. And choice D, the same thing. If you drew a line straight down, you could intersect 2 points. So that's not a function. So the function will be choice B. So all you need to do here is the vertical line test to figure out what's a function and what's not a function. All right, I see your thumbs up, Shanda. Okay. And here's some more about functions. Which of the following is a function? So it's really asking for the definition, what we kind of just described. Each student has a student number. Students will only have one value for their height. The height of each student can be easily measured. The chance to students having the same height is small. Which of the following describes why the following is a function? Why the following is a function? For students in the class, assign their height. Why is it a function? Because of the one value, that vertical line test. If they had 2 values, it wouldn't be, the vertical line test would fail. So think about the vertical line test, one value that gives it a function. Same thing here. For each input, you want one output, not 2. So I want to skip through some of these to see if we can, same thing here. For each input, you want exactly one output. That describes a function. All right, here's something different. Line A is given by this equation, 2y minus x equals 6. So select the equation that could represent line B. So line A is labeled here. Line B intersects line A. So if you notice, line A has a positive slope. It goes from the bottom left to the top right. It's a positive slope. Line B has a negative slope. So the key to answering this question is all about slopes. Slopes and intercepts. So looking at the answer choices, well, first of all, do y'all remember the equation for a line? Does anybody remember what that equation for a line is? Anybody? Okay, the equation for a line is y equals mx plus b, where m is a slope. And the slope is the rise over the run, or the change in the y values over the change in the x values. And the B is the y-intercept. So at the y-intercept, x is 0. So x is 0, and y will be b. So the value is where you intersect. If I have xy plane, wherever you intersect the y-axis, this is called the y-intercept. This point here, where x is 0, you have some value for y, which we call b. Okay, so that is important for this question. You have to know the equation for a line, and you have to know that m means slope and that b means y-intercept. So if you know that, then we can go back to the question. And we know that the slope for line B is negative. So if m is a slope, for choice A, the m value is -1, because that's the m is always multiplied by the x variable. So m will be -1. So that could be it. Choice B, the slope is +3. That cannot be it because we need a negative slope, not a positive slope. For C, the slope is -2. That could be it because that's negative. Choice D, the slope is +0.5. That cannot be it because that is positive. So we eliminate choice B and D because those two have positive slopes. And our line has negative slopes. So now we look at the y-intercept. For choice A, the y-intercept is +3. For choice C, the y-intercept is +7. So we know it is positive, but we're not really sure if it's 3 or 7. So we need to study line A a little bit more. If we knew the y-intercept for line A, we know that whatever the intercept for line B is greater than that of A. So I'm going to write down this equation for line A that they give us on my screen. We'll go back to it. I'm going to write it down. And then we can find out what the intercept is. So I'm going to write it in blue. So the equation they give us is 2y minus x, 2y minus x equals 6. This is not written in the right format. We wanted to write it in this y equals mx plus b format. So the first thing we do is we add x to both sides because we're trying to solve for y. We get 2y equals x plus 6. And then we divide by 2 to solve for y. So y equals 1/2 x plus 3. So looking at this, we know our slope is 1/2. We know our intercept is 3. And we were more focused on the intercept here because we knew that the other line, the intercept is greater. So this is for line A. So for line B, we know that our y-intercept is greater than 3 because on the graph it's higher up. So let's go back to the question. And if line A has an intercept of 3, then we know that we can't choose A because that equals 3. That intercept equals 3. And we know line B has an intercept that's higher than line A. So we're going to choose choice C. It has a negative slope and has an intercept that's bigger than 3. Choice C is correct response. Any questions about that? Lines, equation for a line. Really important that you know the equation for a line. Really important that you know how to find the slope of a line and how to find the y-intercept of a line and what the slope of a line means and what the y-intercept means. And how to rearrange an equation in the format y equals mx plus b. So they gave us the equation for the line A, but not in the right format. We had to rearrange it in the right format in order to identify the slope in order to identify the y-intercept? Kendall, Jasanda, I see the thumbs up. Kendall, good? Awesome. All right. Okay, so here's asking for the mean. Does anybody know what the word mean is in math? What does this term mean?
The average.
The average, exactly. And Kendall, how do you find the average? What's the equation for average?
I don't know the equation, but you add them all up and then divide by how many there are.
That's the equation.
All right, cool.
Yeah, it's the total or the sum divided by the number of items you have. So it says the children in the family are ages 2, 2, 6, 12, 16, 19, and 20. So what's the mean or what's the average of the children's ages? So add them all up. And then let's see how many you have. You have 1, 2, 3, 4, 5, 6, 7. So add them all up, divided by 7. And that gives you the average. So tell me what you get.
B.
You said D as in dog?
B as in
Boy?
boy. Yeah.
And that is correct. Okay. If the company would like to give the impression that its employees are highly paid, which salary statistics would it use? Highly paid. They want to give the highest possible number here. So the president is paid $120,000. The office manager is paid $40,000. 4 persons paid $60,000. And the 4 laborers are paid $15,000. If you want to give the impression that your employees are highly paid, would you give the minimum, the mode, the median, or the mean? So minimum will mean the lowest point. So what is the minimum of the data here? What's the smallest number?
15,000.
15,000. So definitely not that. The mode is the number that appears most often. So which one will be the number that appears most often?
Also 15,000.
Also 15,000. So no, you would not share that. The median is what's in the middle. So if you were to order these numbers from the least to the greatest, what's the number in the middle?
15,000.
15,000. So we got 3 numbers that are the same. A, B, and C are the same. So I'm going to guess it's going to be the mean. And you can add up all those numbers and divide it by 7 to figure out what the mean is. But I'm guessing the mean, I know the mean is higher than 15,000. So correct response is the mean. The other 3, A, B, and C, are all equal to 15,000. Um, 8 pumpkins were picked from a garden. Their weights were 8 pounds, 3 pounds, 7 pounds, 16 pounds, 8 pounds, 13 pounds, 12 pounds, 1 pound. How much greater was the mean? How much greater than the mean was the heaviest pumpkin? So we know how to do means. I think we can skip this one. And I'll let you guys come back to this one on your own. Okay, so here's probability. This is something different for us to look at. A child has 26 pennies, 15 nickels, 21 dimes, 18 quarters, and a coin bank. When a child picks up the bank, one or a single coin falls out. What is the probability that the coin is a quarter? So who knows how to figure out the probability that this coin is a quarter? Do either of you know how to do that?
You add how many coins there are all together, and then quarters is 18. So would it be 18 over 80, but you simplify it?
Well,
So
yeah.
9 over 40.
If you add 26, 15, 21, and 18, you get 80?
Yeah.
And 18/80, oops, sorry, didn't mean to do that. Yes, reduces down to 9/40. Good. So probability is what you want over the total number of options. So what you wanted was a quarter, that's your numerator. The total number of options are your denominator. So 18/80, 9/40. All right, a consultant uses the following graph to justify why air conditioning costs were higher in 2014 than in 2015. What aspect of the graph makes it misleading? So what makes this graph misleading? So the y-axis says the number of days temperatures above 80 degrees. So 2014, the temperature was above 80 degrees on 53 days in 2014, 50 days in 2011, and 51 days in 2015. So the consultant wants to use this information to justify why the costs were higher. What makes this misleading? What do you guys think?
Is it C? Oh.
The vertical axis does not start at 0. So if you said, see, the scale on the horizontal is too large. So I don't even know what that really means. The scale is too large. I mean, it's just 3 years, 2011, 2014, 2015. There really is no scale per se. The bars being different heights, well, they're supposed to be different heights because they're different numbers. So that doesn't really make sense. The increments on the vertical axis are not equal. Well, they are equal. They're all 1 unit apart. So if you just do process elimination, then you would come down to choice B. The vertical axis does not start at 0. I mean, it doesn't really have to start at 0 every time, but if you're trying to justify costs, then, you know, starting at 0 is always a good idea for the purpose of like being completely clear and not misleading. But again, it's not completely wrong not to start at 0. But for the questions asking what would most likely make it misleading, the other 3 choices are not true or not, you know. All right, the next one's about median. So I think we can skip this one. We know that median is the one right in the middle. So you have to order your numbers and then look for the one in the middle. If you have 2 in the middle, then you take the average of the 2. Okay. Here's more about mean, median, and modes. We'll skip that. A teacher gives a test and notes that the mean is 79 points and the standard deviation is 2 points. So here's the first time we've seen standard deviation. The mean is 79. Standard deviation is 2 points. So 2 points above the mean and 2 points below the mean. Which of the following is the best interpretation of the result? The median is equal to 79. Most of the test scores are between 77 and 81. Half of the scores are greater than 81. The lowest test score is 77. The highest is 81. What do you guys think?
Would it be B?
B is correct. Yeah. Tells you that most of the data falls within the deviation, which is 2 points below and 2 points above. So between 77 and 81. Yes, that's where most of the results are. But you still have some lower than 77. You still have some above 81. Very good. The owner of a roller skating rink needs to purchase women's skates. After reading the mean women's shoe size is a 7, the owner decides to purchase mostly women's size 7 skates, because that's the mean. Which of the following statements, if true, best supports? So you want to support the owner's decision. The median shoe size is fairly small. The range is fairly large. The mode is equal to the mean. The mean shoe size is equal to the median shoe size. Which one supports the owner's decision to buy mostly size 7 skates? What do you all think?
C.
C. Yes, the mode, well, that's the one that occurs the most often. So if you have 7, 7, 7, 7, 7, like a bunch of 7s, and the mode, and that's also the mean, that would support buying more 7s than anything else because you have more 7s on the list. Okay, this is about surveys. A marketing company wants to determine consumer attitudes about a brand of soap in a particular city. Which of the following groups would make the best survey sample? So consumer attitudes about a brand of soap in a certain city. Which group makes the best survey sample? Do you want customers who regularly buy the product? Do you want registered voters who tend to vote in every election? Do you want residents who were selected using a random process? You want employees who work for one of the town's largest firms?
Is it A?
Shanda, what do you think?
I think it's C.
Yeah, you definitely want a random sampling. Kendall, you don't want people who just buy the product. If you want to determine the brand of if you want people's attitudes about a certain product, you want to survey people who buy it as well as those who don't buy it. Because your goal as a marketing company is to get more people to buy, right? Or to get people to continue to buy. So you definitely want people who already buy, but not just those who buy. You want to figure out even if you don't regularly buy, you want to understand why you don't regularly buy. And if you don't buy at all, you understand that as well. So if you're just asking people who regularly buy, you're going to get biased information because they already love your product. So a random sampling is what you want to understand the people who don't regularly buy and also understand those who don't buy at all. So you want a random process. Select randomly to get the most accurate data. Okay, let me see what we have after this one. All right, here's a graph. Let's look at this. A company's human resources department is tracking the percentage of employees out sick and the relative humidity of the air in the building. Which of the following conclusions can best be inferred using the following data? So we have all these data points. It looks like a linear function, a strong linear function because the data points are pretty close together. They're not spread out. And according to the graph, the lower the humidity, the lower the percentage of employees out sick. And the higher the humidity, the higher the percentage of employees out sick. So we can kind of infer that if the office is humid, then you're going to have people getting sick from this humidity. So which answer choice would you agree with based on this data?
Would it be A?
No, it's B. When many employees are out sick, the humidity tends to be high. So this is interesting, the differences between these choices. So A says high values of humidity causes people to become sick. B says when many people are sick, the humidity tends to be high. So it's almost, it sounds like it's saying the same thing. So it's like chicken or egg, what comes first, right? So when many employees are out sick, the relative humidity tends to be high. I guess it's about what's on the x-axis, what's on the y-axis. X is your humidity, that's your input. Y is your output, employees out sick. So you want to make sure that when the humidity is high, that's your input, then your employees tend to be out sick. So it's kind of like X versus Y, input versus output. Input is the humidity, the output are employees, versus the input being the employees and output being the humidity. So very subtle difference there. And here's the final question here for the math test. The mayor of a city announces that there were 50% fewer automobile accidents this year than last year. 50% fewer this year than last year. Which of the following is the most important additional piece of information needed to properly interpret these results? So which of these pieces of information do you need to properly interpret the results of 50% fewer accidents this year than last year?
A.
Kendall, what do you think?
I was thinking A.
A is correct. All right. So if I click on next section, it takes you to, well, this is the end, takes you to the bibliography. So this website walks you through, if you start from section 1, this is the about section, about the test. Section 2 is the structure of the test. So you should definitely go back and read this information if you haven't already. And preparation strategies, understand the test structure. Section 3, here's the test design. So you have, the essay, you have a reading section, you have the ELS section and the math section. So we just went through obviously the math section, which is 1 hour, 40 minutes. But you also have an essay, which is 50 minutes, ELS 40 minutes, reading 55 minutes, and then the math. And then you have a 15-minute break. And then you can kind of read more about how the test is structured. And then it goes through all the competencies. So we talked about for math, the competencies being, there's 4 of them here. So number sense, we did examples of number sense, concepts and operations. We did some geometry and measurement. We did some algebraic thinking and coordinate plane. And then we ended with probability, statistics, and data interpretation, which represents the largest percentage of your test is the last few questions we did. So make sure, because remember that they said that they have questions pertaining to most of these competencies, but not all of them. So I will go through this in detail just to make sure you understand everything that's listed here. 3 different aligned items underneath competency 1, and then 4, and then 7, and 7. So go through that. And then you can do practice questions in the essay, and then you can do the questions from the English and the ELA, the reading, and then we just did the math. So, and Dr. Shakir put a few links in the chat. So link to the test guide information, the sections that we did today. So I definitely recommend that you all go back through those math questions. Even the ones we've already did. We skipped through some of them. We got to a lot of them. We skipped over a few of them that were more repetitive. Go through them on your own. If you have any follow-up questions, feel free to send me an email. And then if you still feel like you need more practice, don't feel like that's all that you have. There are lots of study guides as well that you can use to continue to practice and do more questions, especially if you identify your weakest area. So if you feel like you're really strong in the algebra, but you're not so strong in geometry, then make sure you're getting practice with more geometry. Or you're really having trouble doing unit conversions and you really need more practice with conversions, then there's resources where you can practice, doing more conversions. So just go through, use that practice test as a way to kind of judge where your strengths are and to judge what you need most, some more work in. And then focus on your weaknesses and focus on turning those weaknesses into strengths. So Dr. Shakir also says to contact Ms. Bryant if you need some study guides, and she can help you get more practice. Sound good? Kendall, and do you guys know when you're taking your test?
No, I haven't scheduled it yet.
I haven't scheduled it either, but my professor wants me to take it this semester.
Okay, so
at least one portion of it.
Before December?
Yes, ma'am. At least one portion of it, not the whole thing.
Okay. Jashanda, what about you? Before December as well?
Yes.
Okay. Well, you have the rest of September, October, November, you have time. And hopefully this gave you sort of a wake up to like, oh man, I got a lot more work to do. Or, you know what? I'm in a pretty good place. Like I felt pretty good about most of that. So hopefully that gives you a sense of what you feel like you need to do moving forward, at least in the math section. But go back to the website, do the full question, all the questions on your own, and see how you do by yourself. And I think that would give you even more of an accurate representation of what you need to do in order to pass this portion of the test. Okay?
Makes sense.
All right, so let me put my email in the chat, and that way, if you do have any questions for me later on, you can just send me an email.